Good morning. Welcome to a new session of video class. In this class, we will discuss about Gamow's theory for alpha decay. Okay, very important, very significant part or topic in the natural radioactivity. Okay, in the part of natural radioactivity, that is Gamow's theory of alpha decay. Right. First of all, let us talk a few words about Gamow. He is a Soviet-born American scientist. Therefore, he is a Soviet-American theoretical physicist, and of course, his contributions are more in the cosmology. That's why he is a cosmologist also. He is much interesting on the Big Bang theory, and he discovered a theoretical explanation of alpha decay by quantum tunneling. It means that he discovered the theoretical explanation, or he used the theoretical explanation for the tunneling phenomena, quantum mechanical tunneling phenomena. Very interesting. Quantum mechanical tunneling phenomena was used by Gamow in order to explain alpha decay. Okay, and he is the first man who says about the quantum mechanical tunneling. And of course, he invented the liquid drop model and the first mathematical model, which is the first mathematical model of the atomic nuclei. He proposed the liquid drop model for the atomic nuclei, and of course he worked many years on the radioactivity decay, star formation, stellar nucleosynthesis, Big Bang nucleosynthesis. Okay, all these things are collectively known as cosmologenesis and molecular genetics also, and also molecular genetics also. These contributions are excellent contributions, and of course, as far as the present theory also concerned, there is one most important phenomena, that is what is known as the quantum mechanical tunneling effect, which was discovered by him theoretically, and by means of this one he can explain the decay of alpha from the nucleus. Alright. Second thing, let us talk a few words about the natural radioactivity. Natural radioactivity is a spontaneous phenomena. It is a self-disintegration phenomena, self-decay phenomena. Okay? Indeed, it is not triggered or initiated by any other agent. Okay? A nucleus itself starts the decay of alpha, beta, gamma rays at a certain stage of instability. Okay? The natural radioactivity of a nucleus is due to the natural instability. This natural instability arises due to the neutron-proton ratio. In case of neutron-rich nuclei, if the neutron-proton ratio is more than 1.55, in that case such nuclei are very unstable. Such nucleons will combine with each other and they will disintegrate familiarly three types of particles or rays, that is alpha ray, beta ray and gamma ray. This is what is known as the natural radioactivity, and it was discovered by Henry Becquerel. Right. Natural radioactivity is a spontaneous self-disintegration continuous process in which a material disintegrates alpha, beta, gamma rays in a particular order as it like, and it will continue until it gets the stable structure. No external agency like pressure, temperature, electric, magnetic fields and etc. doesn't stop the natural radioactivity. Such a great phenomena it is. No phenomena is equivalent to natural radioactivity because natural radioactivity is not controlled by human being. It is not controlled by any other external field. Okay, it will continue until the nucleus gets the stability structure. Such a phenomena, this one. In this phenomena, it will continuously emit alpha, beta, gamma rays, and of course, in case of and some other particles also, but alpha, beta, gamma rays are most prominent as far as the natural decay is concerned. Right. Okay. In this natural radioactivity, okay, in general, the things are in general the alpha decay and all these things are taking place because of the tunneling effect. Because of the tunneling effect. Okay, right. What is tunneling effect? What is these things? Actually, a nucleus is a potential well for all nucleons. A nucleus is a potential well for all nucleons. It means that no nucleons comes out from the nucleus. Okay, as far as the classical physics is concerned. The energy needed to bring an alpha particle from infinite to a point near the nucleus, just outside the range of the nuclear forces, is generally 25 million electron volts. What it means is the potential well of the nucleus is of the order of 25 million electron volts, whereas the energy of the alpha particles are 4 to 9 million electron volts only. It means that it is not possible to escape alpha particle or to come out the alpha particle from this potential well. Potential well means this potential field. This potential field is the field of the nucleus. The field of the nucleus itself will act as a potential well for the nucleon. All the nucleons will stay inside the nucleus with negative potential energy and with greater stability in the well. Okay, if they want to come out, it is not possible because their energy is much less, that is 4 to 9 million electron volts, when compared with the energy of the nucleus or the potential energy of the barriers or the walls of the nucleus when nucleus is considered as a well. Right. But according to classical physics, it is not possible to comes out. Okay, it is not possible to comes out. Right. Consider this one. Let this is the wall of the nucleus. Okay. Right. Classical mechanics says that if a nucleon or a particle collide the nucleus, okay, collide the wall of the nucleus, if its energy is more than the energy or equal to the energy of the barrier, then only it will cross or comes out. Okay, but the energy of the nucleons are much less when compared with the potential energy of the barrier. Okay, but according to the quantum mechanical, Gamow said that Gamow used one important phenomena, very surprising phenomena, that is what is known as quantum mechanical tunneling effect. According to quantum mechanical effect, even though the particle is not having energy much, if the energy of the particle is much less when compared with the energy of the wall or energy of the barrier, okay, there is always a probability of penetration of the particles through a tunnel. Penetration of particles through a tunnel. This is what is known as the tunneling phenomena. Okay, it means that there is always a probability of tunneling or penetration of the particle by tunneling the barrier and comes out and comes the other side of the barrier, which is known as the quantum mechanical tunneling effect. Okay, quantum tunneling or tunneling refers to the quantum mechanical phenomena where a particle tunnels through a barrier that it classically could not surmount. Classically, it is not possible. If it is want, if it needs to the overcome classically, classical physics says that its kinetic energy or its energy must be equal or more than the energy of the barrier. Okay, this is the classical phenomena. But quantum mechanical phenomena says that it is always possible, or it is always there is a probability to tunneling or penetrating these particles, okay, through the barrier and comes out for the other side. This is what is known as the quantum mechanical tunneling. quantum mechanical tunneling phenomena is due to the wave nature of the particles. We know that de Broglie proposed matter waves. According to the de Broglie's matter waves, particles with high velocities, okay, are associated with matter waves, and the waves that are the matter waves that are associated with these particles can, okay, can survive or can able to penetrate, can able to surpass, can able to move, or can able to tunnel through the barrier and comes out. Okay, that's why quantum mechanical tunneling effect is only due to the wave nature of the particles. Wave nature of the particles. Let this is a barrier. Let this is a barrier. I will explain how tunneling will take place. This is a barrier. Okay, a particle is moving and colliding the barrier here. Particle means it is associated with the matter wave. This is the matter wave. When the particle collides, beam of particles collides. Okay, it means that their matter waves collides the barrier, and there is always a possibility of leaking the matter wave or penetrating the matter wave through the barrier. Okay, while penetrating the matter wave through the barrier, it loses its energy, and of course it comes out the barrier with some energy. Therefore, now the matter wave, okay, propagates the other side of the barrier with less energy. Therefore, its amplitude is less. Its amplitude is less. Actually, its amplitude is more. It means that it is having more energy. While it penetrates through the barrier, it loses some energy, and when once it comes out, because of the quantum mechanical tunneling effect, okay, it has some energy, and with this energy it can move with this kind of wave. Okay, this wave is energetically, this wave is less when compared with the incident wave, whatever it might be. Okay, now the matter waves will come out. It means that now the particles can able to pass through the barrier, or now the particles are said to be penetrate to the barrier, or now the particles are said to be tunnel to the barrier, tunneling to the barrier. That's why it is known as the quantum mechanical tunneling effect. Very beautiful, very surprising, and very excellent phenomena with which, okay, the particles having less energy can able to penetrate through a barrier whose energy is far more when compared with the energy of the particle. It is possible only because of the existence of the matter waves and the penetration of the matter waves. What is the result of the penetration of the matter waves? Because of the penetration of the matter waves of the particles, they will lose energy, and okay, now the wave will become this one. When compared with the incident wave, the energy of the wave that comes out, that passes the other side of the barrier, is less energy, and whatever it might be, there is always some property of penetration or tunneling of the particles, okay, from a barrier. This is what is known as the quantum mechanical tunneling phenomena, and it is purely because of the wave nature of the particles, and by means of this one only, Gamow explained what this one, the theory of alpha theory. Decay of alpha, decay of alpha, decay theory of alpha, or decay of alpha from a material. Okay, right. Now we will continue our discussion with the student material, which is helpful to you. Okay, right. So far I explained what is what and what is the phenomena that is responsible for the okay, generation of alpha particles, even though it is having less energy. That is what is the quantum mechanical tunneling effect. It is due to the what is on the wave nature of the materialistic particles. Now, okay, for the convenience of the students, let us continue the topic with the material that is helpful to the students. Okay, Gamow's theory of alpha decay. Gamow proposed alpha decay to explain what is the aim of the Gamow alpha decay. Okay, what is the aim? To explain the relation between decay constant of the material and energy of the alpha particle, or it gives the okay half-life of the alpha particle and range of the alpha particle, half-life of the alpha particle and range of the alpha particle. Okay, parent material or the material that gives the alpha particles is characterized by decay constant. Decay constant means number of, okay, disintegrations per second. Number of disintegrations means number of alpha particles that will comes out from second is known as the decay constant. Okay, that is what is known as, that is the property of what is this one? The material, the radioactive material, decay constant. Okay, right. What is the property of the alpha particle that will comes out? Property of alpha particle is range or energy. If it comes out with more energy, it travels more distance. That is the more range. More energy, more range. What is the property of the material that gives the alpha particle? That is its half-life and decay constant. Half-life and decay constant are the properties of the are the characteristic behavior of the material which gives the alpha particle. What are the properties of the comes out for alpha particle? It is its energy or what this one? Range. That's why Gamow's theory of alpha decay explains the relation between decay constant and range or half-life and energy. These two are one and the same. Right. Alpha decay is a result of natural instability of heavy nucleus. All these things what I explained so far are actually listed out here. Right. That's why I will go through very rapidly. Every nucleus is surrounded by potential barrier. Okay, this potential barrier is a hurdle for the particle to escape from the nucleus. Okay, every nucleus or a particle generated in a nucleus is said to be there in a potential well. Okay, therefore a particle can able to escape from the well of the nucleus if its energy is equal or more than the potential energy of the well. That is also explained to you. Classically, this is the condition for the decay of alpha particles. Okay, but according to the quantum mechanics, a particle with less energy can comes out from the well. Okay, well of very high potential. Okay, this phenomenon is known as the quantum mechanical tunneling. According to the tunneling phenomena, a particle can overcome. Okay, overcome means don't to comes up from. Overcome means a particle can able to penetrate. Okay, can able to penetrate or can able to tunnel. Tunnel means to dig the what is this one? The hole, dig the hole in order to penetrate the barrier in order to so that it can come out comes from the other side. This is what is known as the tunneling effect. Therefore, tunneling phenomena means the particle can able to penetrate through the barrier, and comes out to the other side, which is known as the quantum mechanical tunneling effect, and this is due to the nature of the matter waves. Okay, this tunneling phenomena is due to the wave nature of the particle, that is the matter waves. Right? In case of uranium 238 alpha particle that comes out from the nucleus, its energy, okay, the barrier energy or the nucleus energy 35.6 electron volts, 6 million electron volts. Whereas the alpha particle is having 4 million electron volts, 4 to 9 million electron volts, which is very, very less. Okay, that's why classically it is not possible, but quantum mechanically, because of the wave nature and because of the quantum mechanical tunneling phenomena, okay, it is possible. Therefore, there is always a probability of penetrating of alpha particles from the barrier to come out to the other side. Okay, due to this effect. Right. Gamow had shown that there is a finite probability for alpha particles to penetrate the potential barrier and escape from the nucleus. Right. Here, in order to explain the Gamow theory, this is a very, 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 very important diagram in which we can able to understand how the nucleus will retain in the nucleus and what happens when they comes out. Right. This is, of course, this is potential energy axis and this is distance axis. This is the origin 0. It means that the center of the nucleus. This is the center of the nucleus. This is R naught. R naught means radius of the nucleus. It means that this region is within the nucleus. Okay, 0 to R naught means this is within the nucleus. Exactly R naught means on the surface of the nucleus. Okay, away from R naught means outside the nucleus. I hope you will understand. This is origin means center of the nucleus. R naught means radius of the nucleus. Therefore, R to R naught means within the nucleus. Exactly at R naught means on the surface of the nucleus. Okay, above R naught means Okay, this is outside the nucleus, outside the nucleus. Okay, right. What is happening in this thing, right? Now, if a particle is within the nucleus, right? If a particle is within the nucleus, particle position R, let the particle position from the center of the nucleus R, let it is R. If R is less than R naught, if R is less than R naught means the particle is within the nucleus. If the particle is within the nucleus, so the particle has negative potential energy and maximum stability. Okay, I hope you will understand. If the particle is on the surface means if R is equal to R naught. If the particle is exactly on the surface, now its negative potential energy becomes positive potential energy. Up to this one it is negative potential energy, and suddenly it becomes a positive potential energy. Positive potential energy means it is now ready to come out. Positive potential energy. Later, if R is greater than R naught, okay, the positive potential energy of the alpha particle gradually decreases and converts into kinetic energy, and after traveling a small distance from the surface of the nucleus, okay, its total potential energy now becomes the kinetic energy. It means now the alpha particle is said to be comes out from the nucleus. This is the actual picture. Very important. Please understand this one. Okay. This is origin, center of the nucleus. This is the surface of the nucleus. Okay. R0 to R naught within the nucleus. The potential energy is negative. If the particle is exactly on the surface of the nucleus, then its negative potential energy suddenly becomes into positive potential energy. If its position is away from the nucleus, outside the nucleus, its potential energy gradually converts into kinetic energy. It means that after traveling a small distance from the surface of the nucleus, okay, the potential energy of the nucleus now becomes kinetic energy. It means that the particle is said to be escaped. It means that the alpha particle comes out from the nucleus. Okay, alpha particle is readily formed. In order to explain Gamow theory, Gamow made some assumptions. What are those assumptions? Alpha particle is readily formed, okay, and available to penetrate. Okay, before the disintegration, let the Gamow said that alpha particle is already formed in the nucleus and it is ready to penetrate. And alpha particles are moving this side and that side within the nucleus and collides the walls of the nucleus, and these collisions are perfectly elastic collisions, right? There is a definite probability to leakage of alpha particles through the barrier. There is always a definite probability to leak the alpha particles through the barrier because of the quantum mechanical tunneling effect and the wave nature. Right. What I explained to you is here. R is less than R naught. Alpha particle is confined to the nucleus and its potential energy is negative and stable. R is equal to R2. It is exactly on the surface. Okay, barrier potential. It means that its negative potential energy becomes positive potential energy. If R is greater than R naught, the particle will come out and its potential energy now converts into okay, at R1 it converts into kinetic energy. It means that at R1 the particle is said to be comes out, right? Quantum mechanics says that moving particle is treated as a wave and therefore alpha particle has a finite probability of crossing the potential barrier. Crossing means penetrating. Crossing means don't think moving out, moving from the up. It is penetrating, it is leaking, okay, it is tunneling, it is digging a hole to move through the the barrier. Okay, right. Let P is the probability of crossing the alpha particle in each collision. What is P? Probability of crossing alpha particle in each collision. In each collision, let P number of alpha particles are penetrating. Nu, frequency of the collisions. Frequency of the collision means number of the collisions made by the alpha particle in 1 second. Right. Decay constant. Okay, disintegration constant. What is disintegration constant? Disintegration constant lambda is known as the decay probability per unit time. Okay, decay probability per unit time means number of alpha particles that decay in unit time. Number of alpha particles that decay in unit time is equal to number of collisions. It means the frequency into number of particles in each collision. Therefore, nu into P. This is the disintegration constant. Actually, we want to derive this one. Right. Let alpha particle move back and forth on the diameter of the nucleus. Actually, when alpha particle moves from one wall to other wall, it travels a distance equal to diameter. Therefore, frequency nu is equal to velocity by distance. What is the velocity? Let the velocity is equal to v. What is the distance? If r0 is the radius, then distance diameter is equal to 2r0. Okay, therefore frequency is equal to v by 2r0. Substitute this one in lambda. Therefore now lambda becomes lambda is equal to v by 2r0 into p. V by 2r0 into p. Now if we know the value of p, okay, we will that is nothing but the ultimate result of the Gamow's theory, and it means that in the Gamow's theory we want to derive log lambda. Okay, for that one we need p value. Therefore log lambda means log lambda is equal to log lambda to the base e is equal to log v by 2r0 to the base e plus log p. Okay, it means that we should know the value of log p, right? Using WKB approximation, there is an approximation, that is the probability of in order to find the probability of leaking the particles, which by means of WKB approximation, p value is equal to log p to the base e is equal to minus 2 by h cross integral r0 to r. Why r0 to r? R0 means on the surface, R1 means where the alpha particle attains the kinetic energy. It means that at R1 only the alpha particle is said to be comes out. Therefore, from surface to R1 we have to integrate. From surface to in R1, the alpha potential energy of the alpha particle totally converts into kinetic energy, and then only the alpha particle is said to be formed and comes out from the nucleus. That's why these are the limits. Please remember that one. 2m, 2m of Vr minus E dr. Vr means potential, E means the kinetic energy. Okay, right. Alpha particle at distance r. Suppose let the alpha particle is at a distance r from the surface. Potential is 1 by 4 pi epsilon naught 2 Z e square by r. Q1 Q2 by r potential energy. Okay, right. At the distance, kinetic energy at R1, the potential energy becomes kinetic energy. Therefore, the kinetic energy is equal to 1 by 4 pi epsilon naught into 2 Z e square by only the thing. Okay, this potential energy becomes kinetic energy only at R1. Only the distance difference is here. It is R. It is R1. Okay, right. Now we will convert to VR. This V into this one. Okay, we need R1 here. Therefore, multiply PE, this one, multiply and divide with R1. Okay, R1 here, R1 here. With the 2ZE square by R1, you will get what is this one? E. But already R is here and multiplied R1 is there. Therefore, now the thing will become so log P to the base E is equal to minus 2 by H cross R0 to R root of 2m into VR simply becomes E into R1 by R. How it is arrived? Take this one, multiply and divide with R1. Here it is R1, here it is R1. Denominator R1 and this will give the E. Therefore, E into, here it is R1 and E. R is in the denominator, therefore it is E R1 by R in minus E. Therefore, E is also a common factor, and that's why you will get to root of 2me is a common factor. Therefore, 2me to the power of half root, that is root value, integral R0 to R1 by R minus 1 whole to the power of half dr. Okay, our problem is only to solve a solution of this integration. For that one, R is equal to R1 cos square theta, R0 is equal to R1 cos square theta naught. Okay, these are the mathematical manipulations, and okay, ultimately you will get to, okay, we will go for this one. Ultimately, on substitution of all these things and R1 value, you will get to the values in the R1. R1 value, E is equal to 1 by 4 pi epsilon naught 2 Z e square by R1. Therefore, R1 is equal to 1 by 4 pi epsilon naught to 2 Z e square by E. From what formula? Okay, from which formula? From this one. Okay. Okay, from this one you will get R1 is equal to 1 by 4 pi epsilon naught 2 Z e square by E. Okay, therefore, after getting the integration value and after substitution of all R1 value, you will get log P to the base E is equal to 2.97 Z to the power of half r to the power of 1 by 2 minus 3.95 z e to the power of 1 by 2. Okay, right. Now decay constant lambda is equal to v naught by v by 2 r naught into p. Already I mentioned there. Already even though that is not there, that is this log form is not there, I explained therefore there itself. Therefore log lambda to the base e is equal to log v by 2 r naught to the base e plus log e log p to the base e. Log p to the base e is okay obtained here. That is the theoretical part of the Gamow theory. Therefore log lambda to the base e is equal to, now it becomes log v by 2 r naught e plus 2.97 z square r to the power of 1 by 2 minus 3.95 z e to the power of 1 by 2 minus 1 by 2 z e to the power of minus 1 by 2. This is nothing but y is equal to mx plus c. This is all constant. V, this one, everything is constant. This is in the m place. Okay, that is also a constant. Only the thing, okay, that means for a given element atomic number is constant. Only this one. Therefore, okay, now there is a relation between log lambda and energy. For the sake of convenience, let us convert this log e to the base e. Base e will be converted into base 10. In that case, okay, log lambda by base 10 is equal to log v by 2 r naught base 10 plus now these quantities will become 1.29 z square r to the power of 1 by 2 and 1 minus 1.272 z by e to the power of half or e to the power of minus half. Now, okay, this is nothing but Geiger-Nuttall law, where log lambda is proportional to e to the power of minus half, e to the power of minus half. It means that the log value of disintegration constant is inversely proportional to the square root of the energy, or disintegration constant is inversely proportional to the range or energy. They are related directly to each other. Therefore, log lambda is inversely proportional to the square root of the energy is nothing but log lambda is inversely proportional to the what is this one? Directly proportional to the range, inversely proportional to the range of the alpha particle, which is nothing but Geiger-Nuttall law. Thus, Geiger-Nuttall law was obtained from the Gamow's theory. But actually here the thing is, Geiger-Nuttall law is the law derived from the experimental results of the natural radioactivity. Geiger-Nuttall law, the relation between disintegration constant and range, or the relation between half-life and range, is nothing but Geiger-Nuttall law. It is arrived from the experimental results. Okay. Therefore, Geiger-Nuttall law, which is arrived from the experimental results, is now derived from the Gamow's theory. It means that Gamow theory is indirectly, directly supported by the experiments. Okay, because it supports the Geiger-Nuttall law, or it gives the Geiger-Nuttall law, where Geiger-Nuttall law is an experimental law or experimental formula. Thus, what is this one? The Gamow's theory of alpha decay is a very successful theory in order to the decay of alpha from a radioactive nucleus. Okay, right? See you in the next class.